的各位来宾
Distinguished guests, welcome to Huawei Top 10 Trends of Smart Charging Network 2024. As we embrace carbon neutrality, a global imperative, the role of electrification in this journey becomes increasingly pivotal. Central to this transition is the charging infrastructure, a vital enabler for the burgeoning new energy vehicle industry. It's at a crucial juncture steering toward high-quality growth. What new changes and technological innovations will shape the smart charging network industry? We'll invite Mr. Wang Zhiwu, President of Huawei Smart Charging Network, to unveil the top 10 trends of Smart Charging Network 2024. Hello to all customers, industry peers, and EV owners. Welcome to Top 10 Trends of Smart Charging Network 2024. I'm Wang Zhiwu. I will unveil the top 10 trends of charging infrastructure this year. I hope we can join forces to understand these trends that will shape the industry and make high-quality charging ubiquitous. First, a recap of the NEV industry. In the past 3 years, development of the EV industry exceeded expectations. We believe the number of electric vehicles on the road will grow at least 10 times over the next decade. Passenger electric vehicles will grow from 18 million to 180 million. The business case for commercial EVs continues to grow, and its number will also increase from 2.44 million to 22.34 million. The rapid growth of EVs will inevitably lead to rapid growth in charging capacity. According to our forecast, charging capacity in the next decade will grow at least eightfold, from the 300 billion kilowatt-hours to 2.4 trillion kilowatt-hours. 2.4 trillion is 10% of the current total electricity consumption. The charging infrastructure remains the biggest challenge of the EV industry. It's also the basis of electric mobility and new infrastructure of future cities. If you can build a charging network, improve EV adoption, then you can build a thriving local ecosystem. Another characteristic of the charging network is it generates recurring revenue. You make one-off investment to grab market. As EV adoption continues to grow, you can enjoy long-term benefits. Next, I will unveil the top 10 trends of smart charging networks. Trend 1. High-quality development. In the past 5 to 10 years, through concerted efforts of industry peers, we have laid a solid foundation for the charging infrastructure. But as the number of EVs grows exponentially, it poses a big challenge to charging facilities. The challenge is twofold. At the macro level, the coverage is insufficient, and the structure of charging stations is not reasonable. 10% of charging service areas in China do not have charging facilities, and the coverage is even lower in rural areas. We're just starting to deploy charging stations there. In terms of the mix, 99% of charging stations are fast or slow chargers. Ultra-fast chargers don't exist. This cannot support the development of pure EV industry. There are 3 more challenges at the micro level. First, O&M cost is very high. Dumb equipment accounts for over 30%. Second, poor quality of equipment. The service life is 3 to 5 years. Charging station owners have to replace them before recouping investment. That's why many owners are suffering losses. Third, service quality is poor. 10% of charging facilities do not work. This intensifies EV owners' rent anxiety. The government has noted this and released 16 documents last year and mentioned the need for high-quality development 12 times. High-quality development has become an industry consensus. In well-developed cities like Guangzhou, Shenzhen, and Chongqing, the government advocates for one charging network. At the core of one charging network is high-quality development. Huawei believes there are 4 ways to build high-quality charging infrastructure. First, a high-level design is needed. Second, unified technologies and standards should be implemented. Third, The government should strengthen oversight. Fourth, a unified O&M platform should be put in place to deliver better charging experience. Trend 2. Comprehensive ultra-fast charging. In the past couple of years, some industry peers asked if ultra-fast charging is a trend. Today, I think it's a pretty clear trend. On the technology side, the third generation of semiconductors represented by silicon carbide and potassium nitride-based semiconductors have been mass-produced. The two mature technologies not only enhance efficiency significantly but also support higher voltage. Higher voltage means lower electric current. This supports rapid development of ultra-fast charging. In terms of cells, powerful 4C cells have been mass-produced since last year. And the costs of 4C cells for ultra-fast charging and regular cells for fast charging are similar, so ultra-fast charging is an inevitable trend. This is reflected in recent car launches. In 2021, only 8 vehicle models supported ultra-fast charging. However, at the Guangzhou Automotive Exhibition at the end of last year, the figure increased to 113, suggesting this is an unstoppable trend. Ultra-fast charging is trickling down from high-end to low to mid-range vehicles. As a result, the number of cars with ultra-fast charging will grow quickly. It is even more valuable for commercial vehicles because for them, time is money. According to our forecast, by 2028, over 60% of electric vehicles will support ultra-fast charging. This will pose a challenge to charging infrastructure. Many slow and fast charging stations need to be upgraded or phased out. Trend 3. Optimal experience. There has been more mention of optimal experience because private car ownership is growing. In 2019, commercial vehicles accounted for over 80% of the total in China. 3 years on, private vehicles account for 87%. The table has been turned. As commercial vehicles transition to private vehicles, this will fundamentally change charging infrastructure because commercial vehicles focus on low charging cost while private vehicles focus on optimal charging experience. The charging infrastructure has a low level of digitalization. It cannot deliver optimal charging experience. There are 3 problems. Charging stations either don't work or they don't work well, or they cannot put EV owners' minds at rest. Less than 85% of charging stations can charge successfully on the first attempt, and there is a lot of noise during charging. In addition, in 50% of the cases, thermal runaway occurs either during charging or several hours after charging. This makes EV owners more worried. That's why many car makers are building their own charging stations in order to deliver better charging experience to EV owners. However, according to our statistics, charging facilities built by EV makers account for less than 5% of the total. They cannot achieve large-scale coverage. To deliver optimal experience requires concerted efforts of value chain partners. They should join forces to improve the charging technologies. We believe there are 3 features of optimal charging experience. First, worry-free. One-stop services should be provided to EV owners, starting with visible charging status. Second, charging process should be really quiet. And it should be successful charging on the first attempt. In addition, EMC-based charging can also help address security concerns of EV owners. Trend 4. Security and trustworthiness. This is often overlooked by industry peers. We believe a secure and trustworthy charging network has 2 features. First, high voltage security. There are more EV models on the road, and they have different battery specifications. This increases security risks. Now, 90% of EVs on the road do not have an effective security alarm mechanism. As EV adoption increases, there is more safety risks. How can we solve this challenge? We need to build an electrical safety protection system for people, vehicles, and chargers, and address the security concerns of EV owners. The second is cybersecurity. The number of EVs, charging stations, is growing exponentially. There are more charging station owners than gas station owners worldwide. Take China as an example. There are over 3,000 charging station owners. Given the large number of EVs, charging facilities, and charging station owners, the data generated from charging network will at least double every year. Such massive data will lead to privacy protection and cybersecurity issues. I think we need to build 5-layer defense mechanism, including detection, protection, domain-based isolation, response, and restoration, so that no one can get in, access, or steal data. What are the criteria for measuring high-quality charging networks that are secure and trustworthy? I think we need to make sure there's no privacy infringement, no electric shock to EV owners, no service disruption, and vehicles do not catch fire. Trend number 5, grid vehicle interaction. This is a hot topic. This is an inevitable trend. Renewable energy sources, wind, solar, and hydropower account for less than 30%. The figure will increase to over 40% by 2030. And this will destabilize grid. In terms of grid consumption, the load on the charging network is uncertain. Now, charging network only accounts for 0.3%, but by 2033, the figure will rise to 10%. This will undermine grid stability. So uncertainties on the generation and consumption side will greatly reduce grid stability. Take Europe. Since the energy crisis broke out, the proportion of new energy sources in Europe increased significantly, driving demand for frequency regulation. Last year, the demand for frequency regulation in Europe reached 4 terawatt-hours, up 8 times from 2020. It includes emergency frequency regulation, primary and secondary regulation. The same thing will happen to China's grid and charging network. How can we enable grid vehicle interaction? I think charging network can play a pivotal role. It's called using bit to manage watt. Deep coordination between grid and vehicles will raise new technological requirements, including high precision regulation, low latency response, V2G, and VPP. Implementing these needs requires concerted efforts of the whole industry. We believe grid vehicle interaction will be here to stay in the long haul. It requires efforts of the whole ecosystem. There will be 3 phases, including one-way orderly charging to one-way response and two-way interaction in terms of frequency regulation and peak shaving. Trend 6. Power pooling. The biggest challenge is the charging network may undermine grid stability. The main reason is charging network has only 10% of grid power utilization. Why so low? There are 4 uncertainties. First, map uncertainty. At the beginning, the electric current is high, but gradually the power will decline. Second, SOC is uncertain. The SOC of the EV that is plugged in is uncertain. Third, vehicle type is uncertain. There are taxis and private cars, light trucks and heavy trucks. And there are also, we are uncertain about the load. Maybe many vehicles need to be charged, or only one vehicle needs to be charged. This leads to less than 10% utilization. The best way to solve the challenge is power pooling. By sharing the power across charging spots, we can improve utilization. Integrated charging stations can accommodate charging demands of different vehicle demands, such as vehicles such as ultra-fast, fast, and slow charging. A small pool can provide a large amount of energy. Power pooling has 4 benefits. First, good experience. It can meet charging requirements of 99% vehicles. Second, for the same number of charging spots and same electricity supply, the charging capacity can improve by 30%. Third, There's no need to build more charging stations. Our charging facilities may be more expensive than regular ones, but it can reduce the mains electricity bill by 40% and reduce the cable cost by 20% because 50% of the cost goes to grid power expansion and cable deployment. Fourth, it's future-proof in evolution. It can evolve towards ultra-fast charging architecture or PV and ESS architecture. This will support sound development of the industry. Trend 7. Fully liquid-cooled charging. Why fully liquid cooling? As charging infrastructure expands, charging facilities have to adapt to more harsh environments. They are not just deployed in shopping malls, supermarkets, public parking lots, but also residential compounds, corporate campuses, industrial campuses, seaside, and even mining areas. Charging stations need to withstand high temperature and corrosion. The conventional air cooling brings corrosive air and dust to electrical boards, which will reduce their service life and drive up the labor cost because of manual site visits. The full liquid cooling architecture has 3 features. First, robust protection. Sensitive electrical boards are protected from the external environment. Second, high cooling efficiency. Third, no dust accumulation and high reliability in the long term. So there are 3 major benefits. First, low failure and high quality reduces O&M costs. Second, over 10-year service life. There's no need to deploy cables or conduct civil work. This ensures higher ROI. Third, it can adapt to all scenarios and provide wide coverage. It ensures worry-free charging experience of EV owners. This is the 7th trend. Trend 8. DC power normal charging. Currently, slow charging facilities are deployed in corporate campuses, shopping malls, supermarkets, underground parking lots of residential compounds, and 99% of them are AC. Another feature of the scenario is electricity is at a premium, and most of it is fragmented electricity at 80 to 100 kilovolts or kilowatts. This faces 2 challenges. First, it cannot integrate with the power grid because it only supports one-way charging. It does not have deep integration with the grid. And campuses have integrated parking and charging and are the core scenario of vehicle-grid interaction. Second, AC charging stations cannot have digital interconnection with vehicles. This will hamper digital experience. So we believe corporate campuses will move to small power DC at scale. DC will support grid vehicle interaction and facilitate digital experience. Of course, such DC facilities are costly, but this problem can be addressed going forward. DC charging has 3 benefits. First, faster charging. It can remove the restriction of 5,000 to 7,000 watts and achieve higher charging capacity such as 10 kilowatts to 40 kilowatts. In supermarkets and shopping malls, only 3 to 4 hours charging will be enough. Second, it supports long-term evolution. It can support digital interconnection and advanced grid response services such as V2G and VPP. It also supports plug-and-play and bonus point settlement. Third, massive deployment. AC charging facilities have 10% grid utilization. If we use DC, utilization can improve to 50%. Then with the same power supply, coverage can increase 3 to 5-fold. Trend 9. Microgrid in campuses. Corporate and industrial campuses will move to a microgrid architecture. Such architecture has 4 features. First, the power consumption model of campuses is stable, be it peak hours or off-peak hours. Power supply is relatively certain. Second, campuses have abundant rooftop space. It's well suited to PV deployment. Take China. Rooftop space accounts for 26% of ground space. Third, electricity price is high. Peak electricity price for industrial use is 1.17 yuan per kilowatt hour, but the cost of generating green power is only 0.4 yuan. Fourth, there's a lot of load shedding. Even in Shenzhen, 25% of corporate campuses only have 1 day for normal use, but 6 days for peak staggering. To solve the problem, I think campuses need to move to PV storage, charger, load, vehicle, and cloud integration. Coordinated cloud management can support efficient coordination between grid, PV, energy, storage, vehicle, and live load. This can maximize benefits. There are 3 more benefits as well. Charger load collaboration reduces impact on the grid. Second, high returns. Green power self-consumption, low costs in power generation, and high revenue in feed-in tariff. Third, high reliability. When electricity is at a premium or when power grid is insufficient, you can discharge power from EVs and provide reliable power supply in corporate campuses. Trend 10, all intelligence. Existing charging facilities are digital silos. Digitalization is insufficient as a network layer and vehicle layer. There's a lack of deep coordination. In the past couple of years, top charging station owners work to improve intelligence and digitalization, but they have only achieved digitalization at 2 to 3 layers, not all of the 4 layers. Huawei believes it's necessary to build an integrated architecture to support grid, charger, vehicle coordination. This will bring 3 benefits. First, better vehicle charger synergy. It includes smart vehicle charger guidance, easy payment, and auto charging upon auto valet parking. Second, better grid coordination. We can build a grid-friendly charging network. It will also support millisecond-level charging response, high-precision intelligent scheduling. Third, digital O&M, load-based management for chargers, remote fault diagnosis, and automatic fault recovery will be a reality. This will lower the O&M cost and support wider deployment of charging stations. In 2023, Huawei worked with customers and partners to deploy ultra-fast charging showcases in over 50 cities and along over 20 expressways. We also deployed ultra-fast charging stations along the G318 Sichuan-Tibet Highway. In 2024, we will ramp up efforts together with customers and partners and deploy 100,000 charging stations to make high-quality charging ubiquitous so EV owners can drive outside the city without any worries. Thank you. Thank you, Mr. Wang, for a wonderful presentation. Gaining industry trends can help you seize the first-mover advantage. Huawei's smart charging network points the direction for tech innovation and makes high-quality charging ubiquitous. Dear guests, that's all for the top 10 trends of smart charging network. Thank you for your participation. Bye.